Okay, so now we'll talk about the skeletal tissue. So first we'll see which structures are formed by skeletal tissue. Okay, so we'll see the structures that are formed by skeletal tissues. Then we'll talk about one of those structures, that is the cartilage. So we'll talk about the properties and different types of cartilages in our body. Then we'll talk about bones. Bones are also formed by skeletal tissue. So we'll talk about the bones, classification of bones, bone markings. What are the bone markings? If you see a bone, on the surface of the bone, you'll see a number of markings. So some places you will see a round structure, in some location you might see a pointed projection or depression. So those are the bone markings. We'll see what are the bone markings we see on the bones. Then we'll talk about the structure of the bone. Then we'll see different types of bone cells, and we'll talk about the bone forming tissues. That's the bone marrow. Those are the things we'll talk in the first part. Skeletal tissues are present in the bones, cartilages, and ligaments. Bones are different than cartilages and ligaments. How? Bones have their own blood vessels. So bones have blood vessels. But ligaments and cartilages, they don't have any blood vessels. Bones have nerves. Ligaments and cartilages don't have any nerves. So those things are absent in the cartilages and ligaments, but present in the bones. But all three structures are formed by skeletal tissue. Now, you already know that in our body we have three different types of cartilages: hyaline cartilage, elastic cartilage, and fibrocartilage. Hyaline cartilage is the most common type cartilage in our body. In which structures you will find the hyaline cartilage? I have already mentioned, I am repeating again. Fetal skeleton. Then costal cartilages. These are costal cartilages. Articular cartilage. That means joint cartilage is hyaline type cartilage. Then also hyaline cartilage is present in the respiratory tract. That means in your trachea, larynx, in your bronchi, you will find the hyaline type cartilage. So just remember those are the locations where you will find the hyaline type cartilage. Then elastic cartilage contains elastic fibers, and elastic fibers provide elasticity. What is elasticity? Elasticity is the ability to change the shape, and you know that you can change easily, you can change the shape of your ear because ear has the elastic cartilage. That is the elasticity. You can easily change the shape, and when you will remove that pressure, it will come back to its actual shape. Fibrocartilage. So let me say in which structures you will find elastic cartilage. You will find in the ear, in your ear, and also in the epiglottis of the larynx. Okay? Epiglottis of the larynx. fibrocartilage. Lot of fibers, collagen fibers are present. You remember the picture, right? And fibrocartilages are found in the pubic symphysis or symphysis pubis, this one, this piece of cartilage that articulates two hip bones together, and in the intervertebral discs. So those cartilages are fibrocartilages. So if I ask you in the test that in which structure you will find a type of cartilage, you should be able to answer. In this picture, they have shown the location of those three different types of cartilages. Let's first see the hyaline. Hyaline, you see the costal cartilage is blue color here. The costal cartilage is articular cartilage. Okay. Then also hyaline is present in the respiratory tract, your trachea, your larynx, and bronchi. Then the fibrocartilage, they have colored with red, so symphysis pubis and intervertebral disc. Also, I told in last class that meniscus in your knee joint is formed by fibrocartilage. Meniscus of your knee joint. And elastic, I have mentioned two locations. One is the ear, and you see the epiglottis in your larynx, that green colored structure, that's the epiglottis. Okay, so remember those two structures are formed by elastic. Okay. Bones. Bones are also skeletal tissue, and we can divide the bones of our body into two groups: axial bones and appendicular bones. Axial bones or skeleton consist of the bones of the skull, the bones of the thoracic case, and the bones of the vertebral column. So, bones of the, I'm repeating, axial bones or skeleton consist of the bones of the skull here, the bones of the thoracic case, and the bones of the vertebral column. Okay, so those are the axial bones. Appendicular bones are the bones of upper and lower extremities, upper and lower limbs. So you see here by two different colors they have shown the axial and appendicular bones. Okay, so we divide the bones or the skeleton into those two parts. Functions of bones. Bones perform a number of important functions. Support, you know that skeleton consists of bones, and the skeleton supports the whole body. If you think individually, your brain is supported by the bones, cranial bones, right? Is supporting the brain. Your pelvic organs are supported by the hip bones, okay? Because you have some organs here and they are being led by the hip bones. So support is number one. Whole body is actually supported by the bones, the skeleton. Protection. You know that your brain is protected by the cranial bones, your heart and lungs are protected by the ribs. So those are the examples of protection. Movement. Bones form joints, and joints are the locations where we move our body parts. That's simple. Bones form the joints, and joints are the locations where we move our body parts. If you don't have any joint, you won't be able to move the body. storage. Some important minerals are stored in the bones. Calcium, phosphorus. Those minerals are stored heavily in the bones. Blood cell formation. Inside the bone you have bone marrow, and bone marrow is the site of blood cell production. Storage of fat and triglyceride. You know that as we get older, the red bone marrow is replaced by yellow bone marrow. And yellow bone marrow is nothing but fat and triglycerides. So inside the bones, particularly in adult skeleton, you will see a lot of fats and triglycerides, and they provide energy. We know that fat burns and provide a lot of energy. Now, we can classify the bones in two different ways. One is by looking the shape of bones. We classify the bones by looking the shapes. That is one way. Another way is by looking the texture or structure. Okay. So by looking those two things, we can classify the bones. By looking the shape, we divide the bones of our body into long bones. Those are long. Short bones. Those bones are short, like height and width almost same, and short, cube shape, and flat bones, like cranial bones. Your sternum. If you see the sternum, this is the sternum. This is a flat bone. Cranial bones. These are flat type bones. Okay. Irregular bones. Those bones of our body don't have any particular shape. They are not long, they are not short, they are not flat. They have a number of processes. So you cannot put them in any of those three, neither long, neither short, nor flat. Those are irregular bones. For example, vertebrae. If you see a vertebrae, you see there are many processes, transverse processes, spinous processes, superior articular processes, inferior articular processes. So those are irregular bones. Okay. So again, the example of long bone, your humerus, your radius, ulna, definitely these are long bones. Right? Your femur. Then the flat bones, I have mentioned that best example would be the sternum, cranial bones. Okay? And then the short bones. Short bones are, you see, the carpal and tarsal bones. These bones are short bones, right? Cube shape. And then irregular vertebrae. Vertebrae is an irregular bone. Another type of bone that is called sesamoid. Sesamoid has been included in short bones, but if you see the shape of that bone, it looks like sesame. What that seed is called? Sesame seed. When you go to the Burger King, you'll see on the bottom we have the white tiny seeds. So if you magnify that, your patella, this bone, looks like sesame seed. So that's why we say patella is a typical sesamoid bone. Okay, so if I ask you patella is what type of bone, you will answer, which is a sesamoid bone. Now, classification based on the texture or structure of the bone. If you cut the bone and see the structure, you will see the hard bone and soft bone. Hard bone is the compact bone, and the soft bone is the spongy. Spongy is also called cancellous. Okay, so hard bone is the compact bone, and soft bone is the spongy or cancellous. Now, why the soft bone is soft? Because if you see the soft bone, spongy bone, the appearance is like honeycomb like appearance, lot of spaces inside. So that's why it is soft. You can easily break it. This is a long bone, and in the long bone you see this part is called the shaft, and this is the upper end, this is the lower end. Okay? Now in the shaft you see the hard compact bone. In the upper end, if you see, you will see thin layer of compact bone, but inside is that honeycomb like soft bone. So you will find the spongy bone inside the head of the long bone. So if you just take a piece of the skeletal tissue or bone from the head, you will see the honeycomb like part inside, that's the spongy bone, and the outer part thin compact bone layer. Okay? So the honeycomb like soft bone is protected by the compact bone layer. Now the shaft part of the long bone is also called diaphysis. So diaphysis is the shaft, and the ends of the long bone are called epiphysis. So long bone has two ends. Those ends are called together called epiphysis. S-E-S is more than one. If you see S-I-S, if you indicate only one, that is S-I-S, epiphysis. And when we say S-E-S, physis, that means we are talking about both ends. So a long bone has two epiphyses and a shaft. Now, if you cut the shaft and see inside, you will see a cavity present inside the shaft or diaphysis. That cavity is called medullary cavity. So inside the shaft part, you have a cavity that is called the medullary cavity. And in early life, the medullary cavity contains red bone marrow, where the blood cells are produced. But as you grow, your red bone marrow is replaced by yellow bone marrow. So red bone marrow is converted to fat. Fat is the yellow bone marrow. Yellow bone marrow is nothing but fat. That's why we say that one function is production of blood cells. Red bone marrow produces blood cells. Another function we say of bone is storage of fat. Okay? So in adult bones, you will see the yellow bone marrow or fat. In early life, you will see the shaft is filled with red bone marrow. Okay, so that's the structure. So again, you see, if you see the structure of the cranial bone, the outer and inner layers are formed by compact, and in between those two compact layers, you will see a spongy layer, the cranial bone. Okay, so if you cut here, you'll see spongy inside, and outer and inner layers are formed by compact bone, like sandwich. Okay, you can give it sandwich-like appearance. Okay. Now, if you see the spongy, you see very claviculae, those spiky things, and the spaces in between. Now, these spaces are filled with red bone marrow, always in adults as well as in children. So, inside the spongy bone, you will always find red bone marrow. This red bone marrow will not be converted to fat or yellow bone marrow. So now we can say that in adults, where you will find the red bone marrow inside the flat bones of the body. But inside the medullary cavity of long bones, you will see the yellow bone marrow. Right? But in very early life, you will see the red bone marrow everywhere inside the bones. Bone markings. On the surface of the bones, you will often see a number of projections. Different types of projections are present. The projections that we see on the surface of the bones are tuberosity, crests, trophinters, lines, tubercles, epicondyles, spine, and other processes. So, tuberosity is round projection. So, if you see on the surface of the bone a round structure, we usually say this is a tuberosity. For example, that's the best example. Here, this is the radius. Okay, there is a round structure here that is called radial tuberosity. So tuberosity is round structure on the bone. Tubercle. So I am jumping down to tubercle. Tubercle is round projection, but if the round structure is small, usually we say tubercle, and if the round structure is large, we say tuberosity. So tubercle is baby tuberosity. Okay. Crest, narrow, prominent ridge. You know that sometimes we use the term crest to indicate the top of the mountain, right? We say the crest of the mountain. That means the top part. And this is an example of crest. This is called iliac crest, the top part of the hip bone. This part is called the iliac crest. So this is a crest. Trochanter. If you see large, blunt, irregular surface projection, large but not round, irregular and blunt, usually we say trochanter. For example, this is the hip bone, you know, this is the femur, you know that, and you see this is a large, irregular, blunt projection. That is called greater trochanter. Okay, so it's not round but large bony mass attached to the bone. Line. Line is line on the surface of the bone. If you see the presence of a line formed by the bone, that is the line. Let me show you line. If you look carefully here, you see two lines, although shallow, but you can see two lines here. Those are called supracondylar lines. Okay? So if you see the presence of line in the bone, those are the lines. Epicondyles. Raised area above a condyle. So when in the lab part today, you'll see the bones, you will see those structures. So lower end of the femur, you have two condyles. Condyles are large articular structures, large articular structures. These are condyles, and above the condyle, if you see here, there is another round structure that is called epicondyle. So above the condyle, you have the epicondyles, raised area above a condyle. Spine. If you see sharp, slender projection, that is a spine. For example, these are the spinous processes of vertebrae. So, like sharp pointed projections, those are spines. Process. If we can name any type of projection as process. Many different types of processes we see. For example, this is the masthead process of the temporal bone. This is the temporal bone. This is called the masthead process. You see this process is kind of round, but this is also a process. See, very pointed, sharp. This is called the styloid process. So we can name any projection we can name as process. Okay? So it could be round, it could be pointed and sharp. So I have shown you those, so just skip this. Now, some projections on the bones help in the formation of joints. Okay? So some projections in the bones help in the formation of joints. Those projections are what? Head. You know that the head of the bone forms joint. For example, this is the head of the humerus, and this head articulates with this glenar cavity here and form the shoulder joint. So if this is the head of the bone and this is the socket, this is the joint, right? So head of the bone forms joint. Another example, the head of the femur articulates with this socket called the acetabulum and form the hip joint. Okay? So facets. Smooth, nearly flat articular surface, that is called facet. If you see the surface of the bone is flat or nearly flat, that is smooth, shiny, and this is another bone, both are flat, so this is a facet. Okay? Okay. Then condyle. I have shown you that large, round, or almost round, articular. You see these two condyles of femur form the knee joint, right? So these are condyles because they form the joint. Rounded articular projection. Ramus, arm-like part of a bone is called ramus. This is the arm. So if you see a bone like this part is the ramus. Okay? So if the bone shape of the bone is like this, arm part is called the ramus. For example, this is the mandible, and you see it's like your hand, and this is the ramus, arm part. Okay? Ramus of the mandible. Okay. Now you see those structures in the bones. Not only the projections are seen in the bones, we also see depressions and openings. If you see depressions on the bones, we name the depressions. The depressions could be different types. For example, if you see a canal-like passageway through the bone, that is called meatus. For example, external acoustic meatus. your outer ear canal. That's the canal-like passage that is called external acoustic meatus. So, canal-like passageway. Sinus. If you see a cavity inside the bone, that is called the sinus. You know that's the term, you know, sinusitis, right? Sinusitis. What is sinusitis? Sinusitis is the inflammation of sinuses. And sinuses are mostly present in our facial bones. For example, the largest sinus is present in the maxilla, this bone. Inside the maxilla, you have a huge cavity. And when microorganisms go there and infect that cavity, that is the sinusitis. Itis is the inflammation, right? So, sinuses are the cavities inside the bones. Fossa, shallow basin-like depression. If you see this kind of depression on the bone, shallow but basin-like, that's the fossa. For example, let me show you a nice fossa. This is the humerus. The lower end, the back of the lower end, you have a nice, you see, depression. Basin-like depression, that's the polycranon fossa. So it is a fossa. Groove. If you see that depression is not basin-like, like long elongated depression, where the blood vessels or nerves can lie. Those type of depressions are called grooves. So long, where the blood vessels or nerves or tendons can lie. For example, you see here, the upper end of the humerus, the upper end of the humerus, you have an elongated depression like this, so the blood vessel or nerve or tendon can lie there. So that's the groove. Okay. Fissure. Fissure is opening through the bone. Narrow slit-like opening. If this is a bone, just think that this is a bone, and if you see that bone has an elongated opening, so something can pass from one side to the other side. Okay, so this is the fissure. The difference between a fissure and a canal is long. This is the bone, and you see this is pretty long distance inside the bone. That's the canal. But if you see like this, you can easily go see from one side to the other side. That's the fissure. Okay, it's not. You don't have to travel very long. Foramen. If you see that opening in the bone is round or almost round, that is called foramen. Okay? If it is elongated, long, like slit-like, this is the fissure. If I make it now round, that's the foramen. This is fissure, this is foramen. Fissure is long, foramen is round or almost round. Okay? So, that's the foramen. We have talked about the diaphysis, that's the shaft, and epiphysis are the ends of the long bone. Okay? Now, the coverings of bone. The bones have connective tissue coverings. The outer surface of the bone is covered by periostea, and around the medullary cavity inside the shaft you have another connective tissue covering that is called endosteum. So periosteum and endosteum. What is the difference? If you cut the shaft of the long bone, if you cut here the shaft part of the long bone, it should be like this, right? So this is the outer surface of the bone, and you have a connective tissue covering here, that is the periosteum. Peri means around, osteum is the bone. So around the bone that is the periosteum. Now, this is the medullary cavity, and around the medullary cavity you have another covering that is called the endosteum. Endo means inside. Okay, so we have two coverings, periosteum and endosteum. Now, the periosteum has two layers. If you see the structure of the periosteum, it has two layers, outer fibrous layer and inner osteogenic layer. Osteogenic layer is very important because different types of bone cells are present there. Which bone cells are present? Osteoblasts. Remember, blasts are young cells. I have told you before that if you see the term blast, that means young, and cyte is mature or old cells. So osteoblasts you will see in the osteogenic layer. Osteoclasts, another type of bone cells, are also present in that layer, and osteogenic cells, those are the cells, they can multiply, stem cells, they can multiply. So those cells are present in the osteogenic layer. Now think the name osteogenic. That means osteo means bone and genesis is the production, right? Genesis is what? Production. So this layer, osteogenic layer, can produce new bone tissue can be produced from this layer. That's why it is called the osteogenic layer. Okay. Osteo means bone, genesis is the production. So osteogenic layer can produce new bone tissue. How? Two ways. Osteoblasts produce just write it down, what I say here, osteo, that will be easy for you to understand, osteoblasts. These are young or old? Yeah, very good. And who produces, who can produce more, young people or old? Young, right, more productive. So, osteoblasts produce the matrix of bone. Osteoblasts produce the matrix of the bone. And osteogenic cells, these are stem cells, so they can easily multiply and produce new bone cells because these are stem cells. Okay, these are stem cells, so they can produce new, multiply and produce new bone cells. Okay. Now, to make the new bone tissue, you need those two things. You need new cells, bone cells, and you need matrix. So osteoblasts produce the matrix part, and osteogenic cells produce the new bone cells. That's how the new bone tissue is formed. You remember the structure of the bone. I showed you the osteocytes, and in between you have matrix. So matrix is formed by osteoblasts, and the bone cells, those tiny spider-like, those are produced by the osteogenic cells. So you got new bone tissue. Okay. Now, the endosteum. Endosteum is around the medullary cavity, the inner layer, and this layer also contains the osteoblasts and the osteoclasts. Now, I'll tell you the function of osteoclast. Osteoclasts are giant cells, huge, big cells, and they love to destroy the bone. So within the bone, you have a type of cells, they love to destroy the bone tissue. So those are the osteoclasts. Okay. So during the formation of bone, what happens? Since the osteoclasts are present in the endosteum, they destroy the bones here, and this cavity gets bigger and bigger because bone destroying cells, osteoclasts, are here. So they will destroy the bones, and this cavity will get bigger. And new bone tissue will be formed here by the osteoblasts and osteogenic cells. So that way the bone will grow in width this way. Okay. The cavity will get bigger, but in the new outer tissue will be formed. So here they have shown the location of periosteum and endosteum that I have shown in here. So same thing. Location of red bone marrow in adults and in newborn infants. So in adults, the shaft part is filled with yellow, right? The fat. So you don't see any. But in newborn infants, the medullary cavities of the shaft are filled with red bone marrow too. So in adults, you will find the red bone marrow in flat bones. But the spongy bone, remember I said that spongy bone will always contain the red bone marrow, will never be converted to yellow. So wherever you will find the spongy bone, you will find the red bone marrow. Make sense? Because I said that spongy bone will always contain the red bone marrow. So in adults, now you think that where you will find the spongy bone, you will find spongy bone in the flat bones. You remember I showed you the sandwich. Inside two compact bones, you have the spongy in the flat bones. And also, if you cut the ends of the long head, if you cut the head, you know that inside you have that soft spongy bone. So you have red bone marrow here, you have red bone marrow inside the flat bones. But in adults, the shaft is filled with yellow. So no red bone marrow is there. So, but in infants, you will find red bone marrow everywhere. Okay, so we have talked about different types of cells in the bone. So in this picture, they have shown different types of cells, bone cells, osteogenic cells, stem cells, then osteoblasts. They produce the matrix. You already know that. And then osteocytes. Osteocytes are much smaller than osteoblasts. If you see, the osteoblast is large, but osteocyte is small. That makes sense, right? When osteoblasts are young cells and osteocytes are old cells. And you know that when we are young, our body size is big, and when we get old, the body gets smaller, right? So that's why you see the osteocytes are smaller, osteoblasts are bigger. Then osteoclasts are bone destroyers. They love to destroy the bones, osteoclasts. And so they must be what? They must be big, giant, right? That is number one. They must have, if you are only big, but you don't have energy, then that doesn't help, right? So you must be big. Also, you must have a lot of what? Energy. And who provides energy? Who are the powerhouses? Mitochondria. Okay, so you will see many mitochondria, many nuclei. Nucleus is the control center inside the osteoclast. So osteoclasts are giant, big, they have many nuclei, and they have many mitochondria inside to make them more powerful. So now they can destroy the bone tissue. Okay. Okay, so we are done with the first part of the skeletal tissue. Now we talk about the second part, the last part. Okay. We have already talked about the structure of the bone. Now then we'll talk about the ossification or osteogenesis. Ossification is the process of bone formation. So ossification is what? It is the process of bone formation. Bone formation occurs in two different ways. Some bones of our body is formed by intrachondral ossification. Some bones are formed by intramembranous ossification. So we will see the difference between intrachondral and intramembranous ossification or bone formation. Then we will talk about the blood supply of a long bone. How a long bone gets blood supply. Then we will talk about the hormones that work on the bones. Okay. Two types of hormones work on the bones. One type of hormones help in the growth of the bones, and another type of hormones help in the regulation of calcium in the body, because bone stores a lot of calcium. So another type of hormones regulate the calcium. Just we will talk about those two types of hormones work on the bones. Then, yeah, so those are the things. Then we will talk about few clinical conditions related to the bones. So first, the structure of the bone. You already know that. In the lab part, I have shown you the structure of a bone. If you see the compact bone, hard bone structure, many columnar structures bundled together that I said you before to form the hard compact bone. Now each columnar structure is called the osteon. So this is one osteon, this is another osteon. Many osteons, they bundle together to form the compact bone. Now if you cut, make a cross section like this, what you will see? You will see many round structures under the microscope. And each round structure is an osteon, right? So this is an osteon, this is another osteon. So first, osteon. Now if you focus on the osteon to see the structure of an osteon, in the very center of the osteon you have a canal that is called the central canal. I have talked about that before, central canal. Okay. Then why that canal is there? Because that canal contains the blood vessels and nerves. So you will see the blood vessels and nerves are present in the canal. And nerves. Now, around the central canal, you have lacunae. Lacunae are the chambers. You remember I said that tiny chambers, and those lacunae contain the bone cells, osteocytes. So lacunae are the chambers that contain the bone cells. So now we can say that this is what? Osteocyte within lacunae. Okay? Osteocyte within the lacunae. Now, in between the lacunae, those spaces are filled with matrix formed by osteoblast matrix. And in case of bone, the matrix is very hard, and that hard matrix is called lamella. So lamella is nothing but the matrix of the bone. Okay? So matrix of the bone is called lamella. Okay? Now another structure, these structures I mentioned in the lab. Another structure you will see, those are fine, very fine, narrow hair-like, thin hair-like channels. These channels connect the central canal to lacunae or lacunae to lacunae, like this. Okay, so these fine, very fine, narrow channels, they connect the central canal to lacunae and lacunae to lacunae. And through those fine channels, nutrition and fluid can go from the blood vessel here to the lacunae. All lacunae will get fluid from the blood, and that is important because lacunae contains the bone cells, and those are living cells. They need nutrition, they need oxygen. So through those channels, the fluid from the blood will go to the lacunae within those channels, within those cavities, and your bone cells will get the nutrition and oxygen. Those channels are called canaliculi. So canaliculi or canaliculi are those fine channels that connect the central canal to the lacunae or lacunae to lacunae. So these are the canaliculi. Okay? So that's the structure. If you know those, that should be good enough. And you see the compact bone they have shown, and osteons. Osteons are also called Haversian systems. Okay. See the blood vessels and nerves in the central canal. Okay. Now, chemical composition of bone. You will see in the bone, organic matrix. That matrix is produced by osteoblasts. We already know that osteoblasts produce matrix. That organic matrix that is produced by osteoblasts and secreted by osteoblasts, that's the osteoid. If you see the chemical composition of osteoid or matrix, you will find ground substance and collagen fibers. Okay? So those two things you will find in the matrix. So again, repeating, matrix is produced by osteoblasts and secreted by osteoblasts. They will produce and then secrete, release. And that matrix is also called osteoid. And osteoid has ground substances and fibers. So matrix or osteoid contains ground substances and fibers. Now, the matrix part or osteoid provides strength and flexibility, because we know that the matrix of bone is very hard and it has fibers, so the strength and flexibility is given by the osteoid. Also, in the bone, you will find minerals. We already know that minerals are stored in the bones. So, minerals form 65% of bone mass. Mainly calcium and also a lot of phosphorus. together we say calcium phosphate. So calcium and phosphorus, those are the main minerals present in the bones. And minerals are responsible for the hardness and resistant to compression. Anyway, so that's the chemical composition of the bone. Now, we'll talk about the ossification, the process of bone formation. Ossification is the bone formation. Now, our body, the bones of our body are formed by two means, by two ways. Some bones are formed by intramembranous ossification, and other bones are formed by endochondral ossification. Now, intra means inside, right? You know that intra means inside, and membranous, that means the bones will be formed from inside the membrane. Bones will be formed in the membranes, inside the membranes. So those bones are formed from the membranes, those are intermembranous. Those bones come from cartilages, those are intercartilaginous or endochondral. Now see here, endo and intra, same thing. Intra means inside, endo means in. Endo means inside, intra means inside. So you can say endo or intra, either is fine. Some places you will see intra, some places they say endo. And cartilage, another name of cartilage is chondro. Chondro means cartilage. So now you can say endochondral or intercartilaginous or intrachondral, all same thing. Okay? So don't get confused if you see different names. Endo, intra, same thing. Chondro, cartilage, same thing. Okay? So those are two ways of ossification or bone formation. Okay? Now, briefly, I want to go into detail. Briefly, I will tell you how the intermembranous and endochondral ossification takes place. So, do you remember I said that all connective tissues come from a single source. Did I say? Anybody remember? A single source? Mesenchyme. Very good. So, mesenchymal cells, mesenchymal tissue is the source of all connective tissues. Your blood, your fats, your bones, your cartilages, all those are connective tissues and they come from the mesenchymal tissue or mesenchyme. So, bones also come from mesenchyme. So, this is a membrane formed by mesenchymal tissue. Okay, a membrane of mesenchymal tissue, and inside that membrane you have the mesenchymal cells, because tissue must contain the cells, right? So these are the mesenchymal cells. Okay, you have many mesenchymal cells inside that mesenchymal membrane or mesenchymal tissue. Now, what happens? Only the mesenchymal cells, those are located in the center of that membrane, will first be converted to osteoblasts. So they will be converted to osteoblasts. which mesenchymal cells? Those are located in the center of the mesenchymal tissue membrane. So now these cells, few cells in the center, will be converted to osteoblasts. So now these are the osteoblasts. Okay. Then what will happen next? That's the step 1. Then in step 2, what will happen? You can write step by step. That will be easier for you to follow. Then the osteoblasts are young or adult? Young cells. And we know that they produce what? They produce matrix. And they produce the matrix which is not very solid. It's like, liquid matrix. And osteoblasts will produce liquid matrix and secrete that matrix here. So you got the matrix around the osteoblasts. Okay, matrix. And then next what will happen? The matrix will get hard, because we know that bone matrix is hard. That liquid matrix will get solid, hard, very hard. And as the time will pass, the osteocytes will get old and will become what? Old cells are what? Old cells are cytes, right? So osteoblasts will get old and they will become osteocytes. And which one is big, osteoblast or osteocyte? Blast is big, right? Yeah. Now, as they get older, the size will get smaller. Make sense? They will get smaller. So now we can draw small cells. These are osteocytes. Since they will get smaller, now you see what will happen. The matrix got solid, hard, and then the osteoblasts got smaller. So the matrix will not be able to move, so a cavity will be formed there. Space will be created because the matrix got hard, and inside that hard matrix the cell now got smaller. So a space will be created, and that is the lacunae. So now you know how the lacunae is formed, why lacunae is there in the compact bone. Okay? And why inside the lacunae you have osteocytes, and why around the lacunae, in between lacunae, you have matrix, and why that matrix is hard. So that's how the bone is formed by intermembranous ossification. Just know those few things I have mentioned. That's interesting, very nice. Now, interchondral or intercartilaginous endochondral ossification. Okay. Most of the bones of our body come from endochondral or intercartilaginous ossification. Most of the bones are formed by intercartilaginous ossification. That means they come from cartilage. First, from the mesenchymal tissue, the cartilage will be formed. Then from the cartilage, the bone will be formed. So we know that whole skeleton in a fetus is a type of cartilage? Hyaline cartilage. You already know. So we also know that whole skeleton will be converted to bone, except very few places. So most of the bones of our body come from hyaline cartilage, because fetal skeleton is hyaline cartilage. They will be converted to bones. So what happens? First, this is the blue structure, is the hyaline cartilage. Okay, so just they have shown one piece of hyaline cartilage in fetal skeleton. So first thing, what will happen in step 1? Just I'll mention the changes, so you write it out. in step 1, two things will happen. A primary ossification center will appear in the center of the cartilage. So in the center of the hyaline cartilage, a primary ossification center will appear. And around the hyaline cartilage, a thin bony collar will be formed. So those two things will happen in step 1. A thin bony plate or collar will be formed around the cartilage, and in the center, middle of the cartilage, a primary ossification center will appear. Now, what does primary ossification center mean? So if this is the hyaline cartilage, okay, this is the hyaline cartilage, this is the primary ossification center. What is this? The cartilaginous cells will be converted to osteoblasts. So the few cartilaginous cells in the center will be converted to osteoblasts, and that location is now called primary ossification center. Okay, then what will happen? The osteoblasts, in this case, just opposite thing will happen than the intermembranous. The osteoblasts, instead of getting smaller, they will hypertrophy. They will get bigger. They will get bigger, bigger, bigger. Okay? So now just think that if all these osteoblasts get big, 5 osteoblasts here, so if they get big, they will occupy more space. Make sense? They will occupy more space because all of them got bigger, much bigger. So they will occupy more space. And then what will happen? At certain point, they can't get any more bigger. What will happen? They will rupture. They will die. So first they will get bigger, and then at certain point they will burst. They will die. And when that will happen, a large cavity will be formed there because the cell membranes have been destroyed. So a cavity will be formed there. That is the medullary cavity. Okay. So if you see here, the cavity has been formed inside the bone. Okay. And the plate or collar will get bigger, and more cells, cartilaginous cells, will be converted to osteoblasts. They will hypertrophy, they will get bigger and will burst, so the cavity will get bigger. Okay? So the same thing will happen, and the cavity will start to expand, will get bigger. Okay? And the bony plate or bony collar will get thicker. Okay? So you see the whole middle part becomes a bone, and a large cavity is inside. Then next, a blood vessel will penetrate, will go inside the bone, and that is another step. The blood vessel will get inside and will divide inside the medullary cavity, will form branches. Now another change is secondary ossification centers will appear. Secondary means leg. Okay, primary is first. So the ossification center that will appear first, that's the primary, and then what will happen? Secondary ossification centers will appear. Where they will appear? That they will appear at the ends of the cartilage. Both ends of the cartilage will get secondary ossification center. Same thing will happen. Osteoblasts will get bigger and will rupture, will die, and will form cavities. And new blood vessels will go there too. So that's how the intercartilaginous ossification takes place. I'll just quickly go over again only the important points now. Okay. First, in step 1, two things will happen. But primary ossification center will be formed where? In the center of the cartilage. Which cartilage? Hyaline cartilage. Okay, number 1. Is it clear? In the center of the hyaline cartilage, a primary ossification center will be formed. And around the cartilage, a bony collar or bone collar, which is a thin plate of bone, will be formed. Then what will happen? A cavity will be formed. How? You know that the osteoblasts will get bigger, occupy more space, and will die. So the cavity will be formed. Then next, new blood vessels will enter and will branch there. Next step, secondary ossification centers will appear. If I ask you, secondary will appear where? In the center or at the ends? This side. Secondary ossification center will appear at the ends. Is it clear? Okay. So new blood vessels will enter there. So that's the intercartilaginous or endochondral ossification. Okay. So it's very interesting, although a little bit you have to spend time, but once you know that what kind of changes are being taken place and how the bone is being formed, that's nice. Now the last thing is see, this is very interesting. Although the whole cartilage will be converted to bone in couple of locations, the cartilage, hyaline cartilage, will never be converted to bone. Will remain as cartilage throughout the life. Where the primary and secondary, those two centers will meet. This is the secondary, right? This is primary. Both are growing, and finally they will meet by keeping a thin piece of hyaline cartilage here. So a thin piece of hyaline cartilage will stay there. That will never be converted to bone. That will keep separate secondary and primary. And that is called the epiphyseal plate cartilage. Epiphyseal plate cartilage. That is a weak point in our bone because you know that cartilage is soft. So if you hit the bone, the head part will get displaced from the shaft because of the thin plate of cartilage there. That's a weak point in our bone. And also at the end of the bones, the hyaline cartilage will remain there to form the articular cartilage because we know that end of the bones will form the joints, right? So the bones will be covered, will remain covered with thin plate of hyaline cartilage to make the surface smooth. So in those two locations, at the end of the bones and at the meeting of secondary and primary, the hyaline cartilage will remain as cartilage, will never be converted to bone. And one is the epiphyseal plate cartilage, another is the articular cartilage. That's why when I said that where you find the hyaline cartilages, one location was the joint articular cartilage. That's the hyaline cartilage. Okay. Now, the epiphyseal plate cartilage is helpful to indicate the age of a person, and this is used in criminal investigations or in forensic medicine because we know that at what age, what's the thickness of the epiphyseal this piece of cartilage. Okay, it gradually gets narrower, and if you see the thickness and the location of that piece of cartilage, you can exactly tell the age of that person. If someone dies and you don't have any other information, you can tell the age of that person by looking at epiphyseal plate cartilage. Blood supply to the bones. If you see the blood supply to a long bone, 3 sets of blood vessels supply blood to a long bone. 3 sets. One set of blood vessels are entering, here you see, in the middle of the shaft. And that is called the nutrient blood vessels. So nutrient artery and nutrient vein. They are present in the middle of the shaft of the long bone. Then another set is present at around the 55 cell plate. You know that 55 cell plate is here between the head and the shaft, and this is called metaphyseal blood vessels. So another set of blood vessels, they enter into the bone where at the meeting point of the shaft and the head, and that set is called metaphyseal. Since we have two ends of the shaft and two ends of the bone, there are two sets of metaphyseal. And then another set is present in the periosteum, that is called periosteal blood vessels. Periosteum is the outer covering of the bone. So those are three sets. I am repeating again. Nutrient blood vessels enter into the bone through the middle of the shaft, and metaphyseal at the joining of the shaft and the ends, and periosteal in the periosteum, the outer covering of the bone. So those are three sets. Okay. Bone remodeling. Continuously, our bones are being remodeled. This is a continuous process throughout the life. Remodeling includes destruction and formation. Both are happening simultaneously. Bone tissue is being destroyed, new bone tissue is being formed. Now, if more tissue is formed and less destruction occurs, then the bone will grow. Make sense? If more formation than destruction, then the bone will grow and will get stronger, thick, longer, stronger. If more destruction of bone tissue occurs than the growth or formation, then the bone will get weak. That's very simple, right? If destruction of the bone is more than the formation, then the bone will get weak and easily breakable, fragile. Okay, now in early life, which one happens? In early life, you know that more formation than destruction. That's why the bone grows, right? Fast. And in old age, destruction is more than the formation. So bones get weak. We know that in old people, the bones are weak because destruction is more than the formation. Okay? So that's the bone remodeling. Okay? Okay, so hormones. Two types of hormones work on the bones. I have mentioned at the very beginning. One type helps in the growth of the bone. They work on the bones and help in their growth. Another type help in the regulation of calcium. They also work on the bones, but to do what? To regulate the blood calcium. So those are two types of hormones. The hormones that help in the growth are growth hormone, thyroid hormone, and sex hormones, testosterone, estrogen. So those three hormones help in the growth of the bone. I am repeating again: growth hormone, sex hormones, and thyroid hormone. sex hormones start to suddenly produced at puberty. We know that sex hormones, plenty of sex hormones are produced at puberty, and that's why you see the kids, they grow, suddenly you will see they grow fast at puberty because the sex hormones work on the bones and help in the growth of the bones. Okay, now the hormones help in the regulation of calcium in the blood are calcitonin, which is a thyroid hormone. Thyroid produces a number of hormones. So calcitonin is one type of thyroid hormone which helps in the regulation of calcium. How? Calcitonin decreases. So remember, calcitonin decreases the calcium in the blood. Okay. Then another hormone that is called parathyroid hormone or parathormone, PTH, which is a parathyroid gland hormone. And this hormone does the opposite of calcitonin. That means parathyroid hormone increases the blood calcium. Okay? So thyroid decreases and parathyroid increases. Sorry, calcitonin, which is a thyroid hormone, calcitonin decreases, parathyroid increases. Calcitonin is a thyroid hormone, parathyroid hormone is a parathyroid gland hormone. So just remember those two hormones, those are very important, and they work in opposite directions. Now, how these hormones work? You know that in your bones you have a cell that is called osteoclasts. Osteoclasts are giant, big cells. They do what? Destroy, right? They love to do what? Destroy the matrix of the bone, destroy the bone. So bone, remember, bone is heavily filled with calcium and phosphorus, you already know, those two minerals. So if you can activate the osteoclasts, then what will happen? The bone will be destroyed more or less if you activate them? More. And if you keep them inactive or suppressed, then what will happen? Bone will be destroyed less or more? Less. Okay. Calcitonin inhibits or inactivates the osteoclasts. So bone will not be destroyed by the osteoclasts, and no calcium will get out from the bone, because if you destroy the bone, calcium will be released. If you don't destroy the bone, calcium will not be released. So calcium will not come out from the bone and will not enter into the blood, so blood level of calcium will go down. Okay? So if you keep the osteoclasts inactive or suppressed, then less destruction of the bone will occur, calcium will not get out from the bone, so the blood level of calcium will not increase. That is one.
So calcitonin inhibits osteoclasts or clasts?
Destroys osteoclasts. Make sense? Okay. Now, in the kidneys, calcitonin does what? You know that when urine is formed, some chemicals also get out with the urine. some chemicals get out from the body with the urine. Now, calcitonin will do what? Calcitonin will let the chemicals get out. Calcitonin will let the calcium get out from the body by working on the kidneys. So, calcium will get out from the body with the urine more, and the blood level of calcium will go down. So, calcitonin works on two organs, on bones and kidneys. On bones, they will suppress the osteoclasts, so the destruction of bone will not occur. Calcium will not get out and will not enter into the blood. And on the kidneys, it will let the calcium get out from the body with the urine. Now, parathyroid hormone will work on those two organs as well as the third organ, that is the intestine, in your gastrointestinal tract. What the parathyroid hormone will do on those two organs, on your bones and kidneys, parathyroid hormone will do just opposite of calcitonin. That means parathyroid hormone will increase the activity of osteoclasts. So, if you increase the activity of osteoclasts, then osteoclasts will destroy the bone more, right? Because osteoclasts they love to destroy the bone. So, when the osteoclast will destroy more bones, then what will happen? More calcium will come out from the bone and will enter into the blood. So, blood level of calcium will increase. So, from the bone, the calcium will enter into the blood level of calcium will go up. It's just opposite of calcitonin. Calcitonin did what? Suppressed the activity of osteoclast. Number 2, parathyroid hormone will decrease the calcium to get out from the body with urine. So, it will work on kidneys and will prevent the calcium from getting out from the body with the urine. So, if you can prevent the calcium from get out from the body, then the blood level of calcium will go up. Make sense? So, you are stopping the calcium from getting out from the body. Okay? So, those are two just opposite of calcitonin. Now, okay, so those are just opposite of calcitonin and will increase the blood level of calcium. Okay. Now, parathyroid hormone will also work on another structure. What is that? Intestine. What happens in your intestine? Just know that it will increase the absorption of calcium from the food we eat. So when you eat the food, from the food, the calcium will be taken into the blood. That is the absorption, right? The process of taking the nutrients into the blood from the intestine. So parathyroid hormone will help in the absorption of calcium from the intestine. So blood will get more calcium from the food in your intestine, and the blood level of calcium will go up. So those are the 3 ways how the parathyroid hormone will increase the blood level of calcium. Okay. Okay, so calcium is very important in our body. these are some important functions of calcium. Transmission of nerve signals, muscle contraction, blood coagulation, secretion by the glands and nerve cells, and cell division. I have talked about this, so now if you read, it will be very easy for you to understand. I have talked about this, so you know that. Here, only one thing you need to remember, that is the concentration of calcium in our blood. Blood concentration of calcium is 9 to 11 milligram per 100 milliliter of blood. This is important to know, because your blood must have the calcium within this range, within this narrow range. The blood calcium must be present in your blood. If the calcium level goes below 9 or above 11, both are dangerous. Both could be extremely dangerous, okay? Because you know that calcium does what? Help in nerve signal transmission, muscle contraction, right? So your muscles will get paralyzed, will not work. So nerve signal transmission will not take place. So that's why calcium is very important. Okay. Quickly, we'll go over bone fracture. The different types of bone fracture we see in the bones. So just I will name those and what type of fracture are those. First, comminuted type fracture. Comminuted type fracture, if you see that fracture, not a single fracture there, multiple fracture. If you see the first picture, you see multiple fractures are present within that area. So that type of fracture is called comminuted type. This type of fracture occurs more in old people. The bone is very weak and soft, so when fracture occurs, at multiple pieces will be formed. Compression. If the pressure falls on the bone vertically this way, that will cause the compression type fracture. Like if someone jumps from height, very high, then what will happen? We know that vertebrae transmits the body weight. So the pressure, vertical pressure on the vertebrae will cause a compression type fracture. Okay. Then spiral. Spiral fracture. If you see the fracture, it's oblique, a single fracture, but oblique, not horizontal, not vertical, but oblique fracture, a single oblique fracture in the bone. That type of fracture occurs more if the pressure is twisted type. Like this is the bone, if I hold the bone and twist like this, then that kind of fracture will occur. That is called spiral. Epiphyseal. You will understand this one very clearly. You remember during the ossification, bone formation, the epiphyseal plate, a thin plate of cartilage, hyaline cartilage will remain between the head, primary and secondary centers, and that is the weak point of the bone I told you at that time. So if you hit the bone, the head can get displaced from the shaft, and that's the epiphyseal fracture. Depressed. Yes.
So, if you like break your elbow, would that be kind of like an epiphyseal fracture? Because like your radial head is spaced from like.
That's epiphyseal fracture. Yes. Depressed fracture. If you take a hammer, okay, and hit on someone's head with hammer on the skull, then what will happen? The bone will break and will go inwards. not outwards, right? The bone will break and broken piece will go inwards towards the brain. So that type of fracture is called depressed. And that happens usually in car accidents or in earthquake if something falls on the head, on the skull. Green stick. Green stick type of fracture occurs mainly in children. The bone is soft but not easily breakable. Remember, in adults the bone is very easily breakable, but in children you cannot break. You can bend the bone but will not get broken easily. But if the break occurs, fracture occurs, in most of the cases in young kids complete fracture will not occur, partial. So bone will not get completely broken, partial fracture will occur, and from that main fracture you see a number of branches, tiny branches will be formed because the bone is very flexible. So a partial fracture, and from that fracture branches, tiny fractures will be seen. So that is the green stick type fracture, mainly happens in kids. Okay. Now after the fracture of the bone, what can happen? When fracture occurs, you know that bones are vascular. That means bones have blood vessels. So the blood vessels will get ruptured, bleeding will occur, and blood will accumulate around the fracture, and that is called hematoma. Okay? So hematoma is the accumulation of blood due to bleeding of at the fracture. Then what will happen next? Fibrocartilage will be formed there. Fibrocartilaginous callus will be formed. Okay? Some fibrocartilaginous tissue will be formed, and then the fibrocartilage will be converted to bone. Bony callus will be formed, and then new blood vessels will be formed there. Okay? So those are the things happen. Okay. Rickets. Quickly go over a couple of clinical conditions. Last part. Rickets are the bending of the bones. In rickets, what happens? The bones get bent. Particularly, you will see the bending of the bones. Which bones? The leg bones. Why? Because we know that the body weight is taken to the ground, or body weight falls on leg bones more, right? Or hand bones don't carry the body weight, the leg bones. So when the leg bones get weak, they will easily get bent because of pressure. Okay? That's why we see more bending in the leg bones. That happens due to lack of calcium or vitamin D. Okay? So in those countries, the kids don't get enough calcium-rich food or vitamin D. They suffer from weakness of the bones. Okay, here, interesting, you see a guy in the middle. He's an old person but very short. That is called dwarfism. Dwarfism is the condition when the growth hormone secretion is less in the body. So if in your body growth hormone secretion is less, then the bones will not grow, right? Enough. So the person will remain short, and that is the dwarfism. So dwarfism is due to lack of growth hormone secretion. So bones will not grow. Now, if opposite happens, that means more growth hormone than normal is released, then what will happen? Bones will grow faster. In that case, the person will get very tall, very big, and that is called gigantism. So gigantism, also called giantism, same thing, okay? Giantism or gigantism is due to increased secretion of growth hormone than normal. But remember, normal growth hormone is required for the normal growth of the body. Rheumatoid arthritis is an inflammatory disease. Inflammation of the joints. Okay? So just write it down that rheumatoid arthritis is the inflammation of soft tissue structures in our joints. Not the bone, but the soft tissues in the joints. That is rheumatoid arthritis. Osteoporosis. Pores means holes. You know that? Pores are pores. So, osteo means bone and porosis indicates holes. So, if you see many holes are present in the bone, that is osteoporosis. It happens more in women than men. Particularly after menopause. After menopause, the chance of osteoporosis increases because of lack of estrogen, female sex hormone. Another is calcium or vitamin D deficiency and low level of thyroid estrogen. Just remember that if I ask you, osteoporosis is what? Number one, happens more in girls or boys. That happens more in girls, and when after menopause due to lack of estrogen. Okay. You see here the spongy bone. Upper one is normal, trabeculae, and lower one has a lot of holes. So osteoporotic bone. Okay. So that's all.